We will graph here the equation x minus 3 squared over 4 minus y plus 2 squared over 16 is equal 1. This is the standard equation of a hyperbola with center at the point 3 and negative 2. Now if you look at this equation, you will notice that the minus sign that usually appears in the equation of a hyperbola is in front of the term with the y variable. This tells me that the vertices of that parabola are on the line that is parallel to the x-axis passing through the center. It also tells us that a squared that appears in standard equation comes with the x variable. And therefore, we can say that a squared is equal 4 and b squared, the other number, is 16. And therefore, we can say that a is square root of 4, which is 2, and b is square root of 16, which is 4. We also know that the value of a is the distance between a center and a vertex. And since we know the position of the center and we know that the vertices are on the line parallel to the x-axis and passing through the center, then we are able to plot those vertices. We'll start with the center and we move distance of a equal 2 to the right to get the vertex, say v sub 1, and we go to the left to get the vertex v sub 2. Now we use value of b to find the rectangle that will contain the diagonals. So starting with the center, we move distance of b, which is 4, up to get 1 point, and we'll go distance of b equal 4 down to get the second point. Once we have those points, we draw a rectangle that goes through those 4 points, vertices, and the points on the conjugate axis. A rectangle that has sides that are parallel to the x and y axis. And the diagonals of this rectangle are going to be the asymptotes. So we draw those lines that contain the diagonals. And once we have those lines, we are ready to graph the hyperbola. The graph of a hyperbola will start at the vertex, let's say vertex v sub 1, and will go up to the first asymptote, and then we'll go from the vertex down to the second asymptote. And we'll do the same with the vertex v sub 2. We'll go up to one of the asymptotes, and then we'll go down to the other asymptote.